All right, well, welcome everybody to our UMA webinar Take 2. Today we're presenting on user-managed access, reaching version 1.0. I'm Eve Mailer, and with me presenting today is Maciej Mikulak. I'm the chair of the user-managed access work group at Kantara, and I'm with ForgeRock's Office of the CTO. And Maciej, why don't you say a few words to introduce yourself as well?
Hi everyone, I'm Maciej Mikulak. I'm the vice chair of the UMA work group and also the chief identity architect at Synergetics. And I'm really looking forward to present the UMA today with Eve. So
you can see our Twitter handles on the screen there, and also the UMA WG handle. And we encourage you to put in questions in the chat. And today we're not muting everybody because we've got a small group. So at the end we'll take questions. We'll leave time for questions. But you can also send questions in Twitter if you like. And we are recording today's webinar, and we'll put that up on the web afterwards. So the news that we're presenting today is that the UMA specifications actually reached a level of finalization that Kantara Initiative calls recommendations. So that essentially is standards, technical specifications called standards. And you can see here that Kantara is calling on organizations to implement these standards in the realm of online web applications as well as IoT systems. So we've been learning that there's implications of UMA both in the world of applications, which we expected, as well as in net-connected devices, which has been kind of the wave that we've been experiencing in the world for the last year or so now, and that's been very exciting. So what we thought we'd do first is to describe the big picture of UMA, sort of what it's about at a high level and what it might mean to different kind of constituencies. So first of all, so I get known as the Queen of Venn, so I thought I'd present a Venn diagram. What is the new Venn of access control and consent? There's a number of emerging technologies that have become really quite popular, and the base technology that's become very popular in what's become known as the API economy is OAuth 2.0. And we can describe OAuth as really primarily being about how you secure API interactions, how you let a client application make an API call securely on behalf of a user. Now, OpenID Connect has built directly on top of OAuth to make portable identity happen in that context. So it's added a single sign-on component to OAuth, and that's been really powerful, and we've seen that of late with some conformance programs being announced, self-certification programs recently. And then UMA, User-Managed Access, takes advantage of both of these technologies and builds on top of them to add an individual-centric approach to both of them. So it adds what we can call a privacy-specific view to the identity and security-specific view of the two of them. So together they make this powerful kind of triad. So that's the new Venn of access control and consent. If you want the one-slide view of UMA, if you're presenting to maybe somebody in your organization, here are some ways that you can describe it. One way you can describe it is it's a protocol. It's a web protocol for doing the job of lightweight access control. Another way that you can describe it is that it's built on top of OAuth 2, as I just said. It's a profile and an application of OAuth 2. Another way to think of it is that it designs a standardized set of RESTful APIs that do the job of authorization, privacy, and consent. UMA is also a work group. It's a work group that does its work inside the Kantara Initiative. And UMA is made up of two technical specifications that, as I said, have reached this level of recommendation, and they're at version 1.0. So those are considered standards now. Now, if you want to take a look at the progress of the standardization in the context of the other things in that Venn that I just showed you, here's a timeline. So as happens with a lot of technical specifications, they tend to have a couple of different versions. So if you look at the progress of OAuth, it had a v1.0 life, and then this experimental phase that was called RAP. And then it reached a 2.0 phase, and now in its post 2.0 phase, starting in 2012 and subsequently, there's been a number of specifications built on top of it to flesh out the rest of the picture. And in fact, UMA has been one of the groups contributing to that picture, particularly with the dynamic client registration work. So it's actually quite a generative ecosystem of specifications that you can see that's been built on top of OAuth 2.0. Now, the OpenID Connect world is interesting. It sort of started with OpenID way back when, which was not built on OAuth because it was started pre-OAuth. But then subsequently, the thing called OpenID Connect started to be built on top of OAuth. And you can see, naturally, it sort of came after. And it was OpenID Connect 1.0 was subsequently standardized by 2014. That kind of makes sense. So it was afterwards. And UMA, whose predecessor was called ProtectServe way back when, ended up getting built on top of OAuth 2.0, although it started its life being built on top of OAuth 1.0 and sort of revised and revised and revised, and ultimately took advantage of OpenID Connect as well, having started to invent things that looked like OpenID Connect, and in fact started to invent things that looked like JOT as well, JSON Web Tokens. And then as those pieces started to be developed elsewhere, said, oh, great, we'd love to point to those and not do them ourselves. The same is actually true for token introspection. We'll get into that in a moment. So, and the two pieces of UMA Core and OAuth resource set registration, a piece that actually is relevant not just to UMA, but also potentially to OpenID Connect and OAuth as well. Those were finalized on March 23rd of this year. So that is kind of the past up till now, looking at those three major pieces. So this picture is what we call the marvelous spiral of UMA. That is essentially the architectural diagram of UMA. And what you see in those bubbles is the major entities, software entities and players in UMA, and this picture represents the benefits that we think UMA brings to the human and maybe the non-person entity parties in the interactions with services and net-connected things. So we say that UMA brings privacy by design to the resource owner, Alice's interactions with services and net-connected things, and in particular with that requesting party over there, so we've named them Alice and Bob. So at a high level, we can say that the use cases here that Alice wants to share data and API access, not with everybody, but selectively among the applications she herself uses, but also with family and friends, and also maybe with organizations like her employer. So maybe Bob is actually her employer, or maybe Bob is her doctor, or maybe Bob is her husband. Another way of seeing this high-level use case is she's not one of those TMI, too much information people. She's a privacy fundamentalist, and she wants to protect her stuff online from being seen by everyone in the world. And maybe her stuff online increasingly is IoT stuff. And then finally, she wants to control access in a manner that is proactive and also convenient, and not just feel forced to tick that consent box over and over, opt-in or opt-out, whatever it may be. So those at a high level are the benefits that we think that UMA brings to Alice's interactions with all those things in the world. Now, from another perspective, we can say that UMA lets those apps and services gain high-quality authorization through loose coupling. So take a look at the resource server and authorization server components that we have here on the screen. OAuth, plain OAuth, has conceptual components called resource server and authorization server. However, in practice, they tend not to be distinguished in the sense of they tend to be run by the same security domain. But in UMA, in fact, the resource server might be run by, let's say, an organization whose business is some kind of business SaaS application, or it's an IoT platform, and they may not specialize in authorization or privacy. There's lots of reasons why a company running a feature like that wants to just integrate to get features around selective sharing, the way they do with billing platforms that they integrate for. Whereas there are organizations and companies that would be authoritative for some resource owner's wishes, think policy, and that authorization server is always on and ready to provide authorization as a service. So in this entire ecosystem that we live in, what we're starting to see is a separation of concerns that quite naturally breaks out the way that we think of authentication as a service, which is effectively what single sign-on is a subset of. Over time, we've seen a number of use cases arise for what UMA makes possible. And I've provided a couple of tiny URLs at the bottom that highlight some of the case studies we've collected. So UMA case will take you to our collection of use cases, and the other two are specific use cases. So healthcare is one that we'll demonstrate today. Financial and small business and tax use cases really lend themselves to areas where, you know, hey, Alice may want to share information with her chartered accountant, or she runs a small business and wants to be sure that her bookkeeper can help her out but only see what the bookkeeper should see. Education with transcripts lends itself to sharing data that resides elsewhere. Personal data stores of the vendor relationship management sort is a use case that is very UMA-friendly. Government-to-citizen use cases, digital media use cases where people are creating their own content and wanting to selectively share them, maybe with a payment use case, as well as enterprise use cases, so where the resource owner is not just an individual, the resource owner is actually an organization. And then finally on the right side, what you're seeing here is the channels to which the UMA architecture could easily apply. It's not just web. It's not just mobile, as we've seen in the OAuth world already. It's not just protecting APIs. It's also when you have net-connected devices. We're seeing a comment here in the chat, potentially use microservices authorization management, even if they are part of the same security domain. That's an excellent point. We've seen that UMA is attractive when you want to do centralized scope management, where you have many, many different resource servers, but you want to control what scopes you've handed out to all the clients from a single authorization server. And I would say that's kind of an enterprise use case with APIs in mind. So great point there. And that's highlighted in this UMA AM 2.0 link, in fact. Some of you may know that there's a group that's been started in the OpenID Foundation called Health Relationship Trust, or HEART. I'm actually co-chair of that group, and it has an UMA connection. So I want to show you this diagram real quick. That HEART group is actually kind of profiling the Venn of technologies that we showed you. And so the way that it's profiling those three technologies is in parts. So there's going to be two profiles for OAuth, in the sense that one profile will focus on security and interoperability of how to use OAuth for patient-centric RESTful health data sharing. And there will be another profile related to OAuth when it comes to using a special health-related API that's called FHIR. So F-H-I-R is pronounced FHIR, and it stands for Fast Healthcare Interoperability Resources. So the leftward profile might be of interest to folks who aren't even in the health game, because it's really just tightening down, sorry about that, all of the kind of knobs and dials of security for OAuth. And that might be of interest to verticals other than health, whereas the rightmost profile would be pretty specific to that health API. And then similarly, there's going to be a HEART profile for OpenID Connect that might be of interest to those outside of health. course, OpenID Connect kind of comes with its own single sign-on API. And then similarly, again, there's going to be a heart profile for UMA that might be of interest generally beyond health, and then a specific API-based heart profile. So you can see there's 5 total profiles planned, where 3 of them might be of interest to folks, and 2 of them are related to UMA. So I think that's a good sign for kind of the UMA ecosystem of specifications and sectoral interest. All right, I'm going to turn things over to Maciej to talk about digging into some UMA technical particulars.
Thank you. So let's take a look at how basically UMA builds on top of the existing technologies, and what are the underlying interactions between different components or different actors of UMA. So under the hood, it's basically, as Eve mentioned, it's OAuth 2.0, and it's really something that we often refer to as OAuth++. It is because what we do is that we use the OAuth protocol to establish various different relationships between the parties, but there's a significant difference between the UMA protocol and the OAuth protocol. It's best to summarize this difference by pointing out two important things. The first thing is that in OAuth, the resource server and the authorization server are often coupled, or there's some sort of a proprietary way of communication between these two components. And in UMA, we specifically allow loose coupling between the RS and the AS. In this case, the AS is able to take on board or provide its functionality to a number of different resource servers, even if these resource servers reside in various different web domains, security domains. And the second thing is that the requesting party, so the individual or the organization that sits behind the client application that accesses a resource, it can be different from the resource owner. So if we think about the OAuth, it's common that the data that is shared from one application is shared to another application for the same user. So it's a single individual who establishes basically a relationship between two different applications. In UMA, the data can be shared from one resource server, but with a different application and with a different user. Importantly, this relationship and this sharing is not done through users maybe runtime consent, but it's really done through based on the user policy, the policy that resides in the authorization server and in the authorization server. Yeah. If we could, right. So let's take a look at the interactions that happen in the UMA protocol, and how different actors interact. So if we take a look at the diagram on this particular slide, we see that the client interacts with the resource server and uses what we call an RPT token, a requesting party token, to get access to a resource. This is the main token in UMA, and it is associated with specific permissions. It's often time limited, so we can have a very scoped and very selective sharing of resources with the client. And this RPT really binds the specific resource server at which access is being sought, at which the client tries to access the resource. It binds the authorization server, the client itself, and the requesting party. We can see that it does not necessarily bind the resource owner, because the requesting party does not have to know who really owns or controls the resource that is being accessed. And another interaction that we see on this particular diagram is that the resource server can register whatever it likes at the AS. So there is an interaction between the resource server and the authorization server for the purpose of allowing the resource server to participate in the UMA flow. the resource server uses what we call a PAT token, a protection API token, to interact with the AS and register resources for protection. It also uses this token to register permissions which may be added to the previously discussed RPT token, and it also may use the token introspection endpoint, which is used to basically check which permissions have been really added to an RPT token. So these three endpoints, the resource registration endpoint, the permission registration endpoint, and the token introspection endpoint are all a part of the protection API at the authorization server, the API that is exposed for the resource server specifically. And to also highlight the PAT token really binds, as we see, the resource owner, the resource server, and the authorization server. On the next diagram, we can see that the client, in order to interact with the authorization server, so to be able to win access for a specific resource hosted at a resource server, it interacts with an authorization API that the AS exposes for client applications. This authorization API is currently composed of just a single endpoint. In previous versions, as we'll discuss, these were multiple endpoints. This endpoint is called the RPT endpoint. The RPT endpoint exposes such functionality as issuing new tokens to clients, but it also acts as an endpoint where new permissions can be added to existing RPT tokens. In order for the client to be able to interact with this endpoint and the authorization API as such, the client has to present an AAT token at the AS. The AAT is an authorization API token, and it binds the requesting party, the client, and the authorization server. Importantly, during interaction between the client and the AS, there has to be what we call a claim gathering flow, and we'll discuss that later during the presentation. This claims gathering flow, importantly, allows for a very flexible trust elevation and basically attribute-based access control or claims-based access control.
So yeah, maybe a little bit of a color commentary on what you've just seen here. The PAT and the AAT, they're essentially embedded OAuth flows right inside the UMA flow. So there's kind of a reciprocal, Alice has to consent to the resource server and the authorization server working on her behalf, and that's what that protection API token is about. And Bob has to consent to the client working with the authorization server, because he may have to reveal attributes about himself in order to get access. So that's just plain old OAuth flows, but the concepts behind them are really important because they represent consent for these two autonomous parties to work together to achieve Alice to Bob access. We have this notion of binding obligations, which we'll talk about more in a moment. The notion of, hey, these parties are in one way or another promising something to each other in order to get access or share access. And it's kind of a peer-to-peer notion of, hey, you got to give to get on the internet. So it seems like a lot of tokens, and I've been working with my folks inside ForgeRock about, what's the experience like of, building services on top of UMA, and the experience what I heard back was, oh, it's pretty easy, but there's a lot of tokens. Well, in the case where there's a lot of tokens, it's because you have to respect that Alice and Bob both have rights, whether they're people or whether they're companies or whatever. You have to preserve their rights. More color commentary, the significance of that resource set registration. When you have a resource server and an authorization server separate, even if they're living in the same domain, even if it's sort of an enterprise architecture proposition to have them loosely coupled, the RS is authoritative for whatever its API does. It may be making money off of that API. It's an API economy after all. So whatever the verbs and objects of what the API can do, the things you can do with the API and then the scopes over them, it needs to remain authoritative for them. And if the AS literally does live in another domain, the AS needs to be informed about what is possible to do so that Alice can associate the subjects that she desires to be able to get access to those resources and the things that can be done with them there. We've got a question in the chat, why do you call it loosely coupled? So the potential for having the resource server and the authorization server to literally live in different security domains, for example, be run by different companies, is what one of our goals was. Now, there are some use cases where they might be run by the same company and live in the same security domain, in which case you have opportunities for optimization, and we actually do have what we call extensibility profiles in the UMA spec, the UMA core spec, to let you sort of back off of having to go all the way out to HTTP when you know for certain that, for example, the same hunk of software is performing both the AS and RS roles. But it's very valuable in a lot of circumstances to centralize the authorization server role and have a different company perform that role, and then have many, many different resource servers in the world use that authorization server, much as you would have authentication relying parties rely on a single identity provider that lives in a different company. It's very similar to that. So that's what we mean by loose coupling. Okay, Maciej, you want to take this one as well?
Of course. So we discussed that in order for the client to be able to access protected resources at the resource server, it has to have the RPT token. And this RPT token, as we said, contains certain permissions, and the client has to win or sort of get these permissions associated, maybe gradually, with the RPT token, and it does that through the interaction with the authorization server, which sort of can even elevate the requesting party's trust in order to access the policies. We call the flow of getting the new permissions associated with an RPT token the claims gathering flow. And this particular flow can sort of have three different paths. So in the first sort of path, so the client can sort of proactively push a certain information about the requesting party, the information which may be used to assess an access control policy that has been set by a resource owner. This information may include, for example, an OpenID Connect ID token, maybe a SAML version, a scheme record, or any other information that may have been pre-agreed between the authorization server and the client. For example, if we have a particular trust framework, or we operate within a particular trust domain, then maybe there's even a proprietary way that the client can communicate to the AS. So it's all very flexible in how UMA allows this interaction to happen. However, if the client cannot provide the information directly, it may be told by the authorization server that the requesting party should be redirected to the AS, and the authorization server will be able to get the information directly from the requesting party. So it's a situation where the client is a claims unaware client, and after redirecting the requesting party, the AS may, for example, ask the requesting party to maybe log in with federated login, or fill in a form, for example, by providing the reason why access is being sought by this particular party, or maybe click on I agree button. So it's a very flexible model as well. And the third thing is that in case the requesting party and the AAT token, which binds the AS, the client, and the requesting party, has been issued in a way that it's considered by the AS to be too weak. So, for example, initially the requesting party only logged in with username and password at the AS, and this is how the token was created. In this case, the AS may even ask the client to basically redirect the requesting party again, and for the requesting party to go through maybe a two-factor or even authentication in order for the AAT to be issued with sort of a stronger level of assurance for the client.
I see a couple of questions in the chat here, and I'll try and address them really briefly. So this is an area of pretty significant variability for UMA. It's kind of a framework right here around trust elevation. And claims gathering, the two bubbles at the bottom, is sort of one mechanism, and then the authentication is another kind of upstream of claims gathering method. And the reason there's so much variability is precisely because the standards for how you ensure that ALICE's policies can be met it's up to ALICE, it's up to the authorization server's capabilities, and it's up to what we call here the operative trust framework. If you think of single sign-on, for example, these days, federated identity, quite often it's up to an arrangement among all the parties what attributes you would send along with the user to establish what the user can get access to in the service they're trying to get access to. This is much the same. So you can imagine in an enterprise circumstance, to use a very common example of single sign-on, you need to know things like roles and groups. So if Bob wants to get access to something of Alice's and Alice wants to know that he's bob@gmail.com, and she wants to know that that email address that he controls is verified to within an inch of his life, that might be something that she and the services acting on her behalf want to establish to within an inch of his life. If it's a healthcare circumstance and there's a healthcare trust framework operating where all of the services in the ecosystem want to be sure that Bob is a doctor accredited by the American Medical Association, that's a very specific kind of sectoral circumstance where the applications will have to handle that specific kind of test. So the policies will have to handle it, the interfaces for ALICE to set that will have to handle it, and the claims gathering will have to handle it. You also ask, what is the client? It could be a web client, it could be a native client, same as what you see with OAuth and OpenID Connect today. Hopefully that answers the question. In our Take-Two version of this webinar, we've added what could take a very long time to do slide, and hopefully it won't take too long to do, but we do have the steps outlined here. So Maciej, I'm going to be under your control as you walk through the steps. Do you want to do it real quick? I'll give you a budget of 2 minutes before we get to the demo.
All right, okay. I thought that you would be carrying the slide, but
oh, you want me to do it? I'll do it. I'll do it. This should be fun. All right. So we have a walkthrough here of the high-level flow because we were asked for this, and I thought it would be interesting to include this in our Take-Two webinar. We have some out-of-band actions that ALICE takes. She chooses which resources to protect, or the resource server lets her know what resources can be protected, and that's out of band. As well, she sets policies. The reason that policies are out of band is that's an entirely internal to the authorization server activity, so it's not exposed on the wire. It's not part of UMA. We're assuming for this flow that she agrees in that embedded OAuth flow. She consents to the resource server and the authorization server working together. Once the PAT is issued, that is to say the OAuth token with the right scope is issued, then on an ongoing basis the resource server registers whatever resource sets and scopes are to be put under the authorization server's protection. So you can see the resource server has an OAuth protection client that works with the protection API. Now Bob and his client get to work trying to hit a resource that is under protection. And when that happens, it gets blocked. And so the resource server says, hey, I got a live one here. I have to register a permission, which means Bob attempted access, and so the resource server registers the nature of the attempted access, essentially, to some level of depth, a resource set and scope that would suffice. And it gets back a permission ticket from the AS. And the RS says, hey, look, you got an error, but here's the AS you want to go to with this permission ticket. If Bob didn't have an AAT already, he has to get one. So we're going to assume that happened. I've just put it as dotted line for now. And now the client can get to work saying, look, I need authorization data in order to get to the thing I wanted to get to. And to make that call, it needs to present the AAT because it's a protected API. we are assuming for a moment that a claims gathering flow happened for the sake of not making this slide too big. And a requesting party token is returned with the necessary authorization data. So Bob and his client reattempt. Bob, we'll show you in the demo that most of these arrows are not experienced by Bob or Alice. The client reattempts. The RS says, well, I was just presented with a token, and from now on it's going to look a lot like plain OAuth. The RS says to the AS, look, I got a token. It does token introspection. What's in this token? Here's what's in this token. Aha, what's in this token looks good to me. Here you go. Here's your resource. Phew. All right, take it away, Maciej.
Thank you. So let's take a look at what are the changes in relation to the existing standard, so the version 1.0 in relation to earlier drafts. There are some significant things that change, and I'll start with the resource set registration. So one of the specifications that the work group came up with. So firstly, the scopes that are registered by resource server at the AS no longer have to be strictly URIs. Previously, this was a requirement that only URIs that resolve to JSON descriptions can be registered. Now we can use plain strings, which allows for a greater flexibility. And moreover, in order to register a resource, the servers used put methods, and they were using their own identifier. So the identifier was generated at the RS, and it was registered at the AS. It's now changed to basically a post method, an HTTP post method, and the AS is responsible for generating an identifier for a particular protected resource. Moreover, in order to support discovery at the AS, the resource servers can now register a URI, and this URI is specifically defines the location at which the resource could be potentially accessed by client applications. And as far as the core UMA specification is concerned, there was one major change in relation to how clients interact with the authorization server. This change basically simplified the RPT issuance flow. Previously, we had two separate endpoints where one was responsible for issuing empty RPTs, and the second one was responsible for associating permissions with existing RPTs. We now only have a single endpoint. Moreover, resource servers can now register permissions eagerly. So even if the client does not present any token at the RS, the resource server can already register permissions which would allow the client to access this resource. We also worked heavily on the trust elevation capability, which is now called Meet Info. And this was because we now support both claims gathering negotiation, which is as discussed either for claims aware or claims unaware clients, but also we now support step-up authentication, which as discussed is in relation to strengthening sort of trust in the AAT token. We also changed the PAT and AAT OAuth scopes to be plain strings. Previously, these were URIs.
All right. So it is time to do, a demo, which I'm going to do by showing you a video to minimize problems, because I was discovering some problems when I tried this a little bit earlier. So what I'm going to do is show this video and let me just close that for now, and narrate. So what I'm showing you here is the early open source code from ForgeRock's OpenUMA project. This is actually code that you can download and play with yourself. It is early, but it's a demonstration that we showed at the HIMSS Healthcare Conference recently. So the use case is kind of a wide ecosystem, multi-security domain type of use case. and it involves Alice and Bob. Actually, Alice, Carol, Bob, Ted, and Alice. So you see that Alice actually many years ago went to Unseen University, and many years later she still uses Unseen University's UProtect identity provider and her alice@unseen.edu login and email address. As many people do with their universities, they use their email addresses. And so it actually, UProtect is an identity provider respected throughout the world and used by some relying parties. So she's heard that the UProtect service run by Unseen Edu is offering a new service. It's not just an identity provider, it's also become an UMA authorization server. So it's willing to be a centralized hub for the management of selective sharing. You can see here that it uses two-step verification, and it's actually an identity provider that's part of the InCommon Silver Federation, and it's willing to be, she's got profile attributes, and it's also got this shares tab, which is where the applications of the world that are willing to be UMA resource servers would put the resources that would be registered if she had any yet, but she doesn't have them. So UProtect as a sort of strongly authenticatable IDP is used by a lot of relying parties out there in the world. So she's just checking out this service for now. Nothing really shared out of here yet. So she closes that, and it turns out that she has to go to the doctor. She's got a medical problem, and she goes to a new doctor, which is Dr. Bob. And Dr. Bob runs the Blue Health practice. And the Blue Health practice uses the Be Healthy electronic health record portal. So it all starts with B, so you can remember that it's Dr. Bob. And he tells her, hey, if you want to get a login at this Be Healthy EHR portal, you can. And so she goes to the portal, and she realizes that she doesn't have an account. She has to go to the Create an Account link. And you guys probably all know the experience of registering for an account very, very well. There's a lot of fields. And if she weren't on a PC, that would be a horrible experience filling it in. So we like the experience of having the opportunity of, hey, registering with UProtect. It is willing to be a relying party for the wonderful UProtect IDP. So she takes advantage of that opportunity. So she logs in with alice@unseen.edu. And as we saw before, uses strong authentication. And so she sees something here, which is a consent screen. Now the consent screen has two interesting bullets here. The second bullet says identity attributes including address, email, in fact, all the fields that she would have had to pump in by hand and by value. Those represent the OpenID Connect scopes for it being a relying party. But the first one says central protection of your web resources. That's Be Healthy willing to be an UMA resource server so that UProtect can be an UMA authorization server for it. So Alice says, aha, that's awesome. I totally would sign up for that. So she clicks allow to set up both of those relationships all at once. It didn't have to be done all at once, but in that case, it was presented to her as an all-at-once opportunity. So her information is filled in. This was all done with OpenID Connect claims and extension claims, as a matter of fact. So she registers for the account. She now has her record, and she does something that is very typically done with EHR records, which is she wants to share out her allergy information with her husband Ted. Sorry, she's not married to Dr. Bob. So there's a share button there, which you often see in EHR portals to share out your allergy information because she's about to go on a trip and she wants to make sure that her husband Ted knows all of her allergies. Typically, this is done proprietarily on the back end of the EHR system. In this case, you see that UProtect is brought up because the allergy resource set was registered on the back end with UProtect, and UProtect now knows what kind of resource set this is, and it knows that Be Healthy can have view and import scopes over allergy types of resource sets. So she selects view versus import. That's what she wants her husband Ted to do. And we're going to assume for a moment that Ted is going to be able to view this with a default configured client. And I'm not going to show you Ted actually getting access to this for the moment for the sake of time. And so she can now see, she can confirm, I think, yeah, there's a click on advanced. She's shared with Ted. This is a policy, and I think Bache was just explaining that the policy has been captured in the authorization server in some way that's internal to the UProtect authorization server. So she's just done that at this resource server and her central UProtect authorization server. Now, it turns out she's got another health problem, which is that she's got a heart condition. And so she has to actually have what's known as an ICD, an implantable cardiac defibrillator, put in. And so Dr. Bob actually does that. Now, these days, that turns out to be an Internet of Things device. It's connected to a cloud service. And this ICD that she had put in is run by the Happy Heart company. And Happy Heart runs a cloud. And they've given her a cloud account at the Happy Heart cloud. And so she's created an account there. And what she needs to do is log into that account and bind the account to the device that's now in her body and ensure that the device can represent her correctly so that the device, when it's generating data, acts on her behalf. So she logs into her Happy Heart account, and this is just a local account that just has her, username, alice@unseen.edu. And she needs to bind the account, the service, to the device. So she's going to put in, she has to identify the device, which turns out to be the ICD 500. I like to say it's the fastest ICD on the market. And she needs to put in the serial number that her doctor gives her, as part of the packaging of the device, and so that she can sort of make the triangle of her and the device and the service bound all together. And once they're all paired, now an OAuth token can be generated so that the device can sort of act as a proxy for her. So here you see the heart data representing her. And what do you know? This service is prepared to be a resource server with UMA centralized management, again, on her behalf. And so if she hits that share button, what do you suppose will happen? It's a little bit of a different order from the last time we saw it. In this case, the Happy Heart company is the data custodian. This is what the healthcare IT folks would call it, of this health-related data. So when she hits the share button this time, what happens is she hasn't yet associated the Happy Heart resource server with any kind of authorization server yet. So here it's assumed that her default is UProtect, although it gives other options. So she associates it first and foremost with her chosen UProtect authorization server. So she has to associate it first, and then, since what she wanted to do was share out that data, she does that same consent flow that we saw before. So she's joining them together. That's basically the PAT issuance, the Protection API token, that first bullet. As soon as she does that, it is able to pump her right into the ability to share out that data. And this time, she doesn't want to share it with her husband, Ted. Maybe he wants her heart data. But in fact, she wants to share it back with her doctor, Bob. So kind of interestingly, her doctor isn't really in control of this data. She's more in control of her data than her doctor is, and she's going to share it back with her doctor. So she types in bob@bluehealth.org any moment now. Any moment now. There it is. And she is, this policy creation interface is going to assume that her client is actually, the client that she selected is, in this case, the Be Healthy portal in the role of a client this time, not in the role of a resource server. And those view and import options that were just shown came from the Happy Heart company saying, hey, over a Happy Heart data resource set, those were the options. And here you can see the value of having a centralized management place for multiple resource servers in your life coming from different places. And she could come back here later and say, you know what, I changed doctors, I want to change where this data goes. I wanted import to be added to view, so on and so forth. So here you see Alice looking from the resource server at her heart data. And now let's go back and be Bob for a second, using Firefox instead of Chrome. So, you know, Dr. Bob gets into the Be Healthy portal not to be a patient, but actually to do his work for the day. So he goes into the Be Healthy portal and logs in the morning to just, you know, do his work. And once he logs in, he actually gets a number of messages, and he sees he has one new message for the morning, and he sees that device data has been shared with him by one of his patients. So when he clicks on it, an interesting thing happens. What he sees is, hey, sorry, that's protected. Protection has been stood up in front of this. If he wants to see this, he's going to have to reveal essentially PII about himself. What this is saying is, you haven't set up an AAT, an authorization API token yet, with this authorization server. So on an infrequent basis, maybe a one-time basis, you're going to have to do this acceptance flow before you interact with uProtect, which has stood up protection in front of this Happy Heart resource. So he says, well, yeah, you know, my practice does a lot of stuff with uProtect. I got to set this up. So he's willing to become known to uProtect, and he goes ahead and does that. And in the doing, using the Be Healthy portal, which is a smart client, which was willing to push data about him, and uProtect was willing to accept it from that client, you can see that on the basis of logging in as him, not having Alice share her password with him or whatever, or not on the basis of being sent a secret URL that could get out into the wild and reveal private data about Alice, he can now get access. So that's the UMA proposition. Any questions about that flow before we return to the slides? Okay. Great. I know there's been stuff going on in the chat. Excellent. So now we're into next steps. Macha, you want to tackle this one, do you think? People are probably tired of hearing my voice.
Of course, not a problem. If, do we still have time just to maybe at least show the policy visualization? What do you think about that?
Oh, I'm so sorry. Yeah, let me switch. I'm so sorry. I forgot about that. Let me do that. Let me get to the, forgive me, I forgot. Let me stop sharing and go to you. Change presenter, forgive me. Here you go.
Right. Is the are the slides visible?
Yep.
All right. Okay. Okay. So what I'd like to do is just to present maybe just to talk about some of the policy visualization techniques for NuviAM. That's yet another authorization server from Cloud Identity and more recently Synergetics. And I'd like to present how sort of this functionality is out of band of UMA. So this was one of the questions that at the chat, why is it not a core part of the protocol? So NuviAM, again, it's a system that is an authorization server. It interacts with with protected applications and with client applications, and it can act as a part of federation. And I'll basically, since we are short on time, I'll try to just go to the screens which basically describe the policy setting and what the user really gains by having the central point of control over distributed data. So the first thing is that if we take a look at this screen, we can see that we can add a new policy for example, for ourselves. So this is a case for Alice to Alice sharing. So Alice is sharing some information between different applications. So she's selecting the applications like Personal Data Service or eHealth Vault. is selecting permissions and can add a policy. And when a policy gets created, she can basically view different policies for the resources that she controls at the authorization server. In this case, we can take a look that there's a particular resource registered at the authorization server. So this is one of the views at the authorization server. The resource has a set of authorized applications. Each authorized application has a set of permissions associated. So these are the permissions that the application has when accessing a resource. There's another type of policy where there's a resource, and we can view the policy by specific individuals who can access the resource using well-defined applications. So in this case, the X-ray resource can be accessed by James, who might be a doctor, for example, and can only use a single application for management of that specific resource. Again, by having a central point of control, we can view all kinds of audit type information. So we can see the resource history. We can see, for example, how the resource was accessed, how we amended policies for this particular resource. We can view the global audit log, so we can see how our resources are sort of living on the web. So we can see who accesses what happens to policies, etc., etc. We can also view that sort of information by application. But a very interesting thing that we've been looking at is also this policy visualization. So if we take a look at a particular resource registered at the authorization server, and what are the applications that can access this server, this resource, or authorized contacts that can access this resource, we're trying now to look at how we can visualize that in some sort of a graph form which we could possibly traverse. This is just a conceptual work, but it sort of maybe shows also the benefit of having UMA as this technology which allows us to have the central point of control over vast amounts of information that can be spread across a number of different and distributed resource servers.
Cool. Good stuff. All right. Wonderful. All right, so just a quick, we've been answering questions all along, so hopefully there won't be too many. We'll just maybe go a couple minutes over if folks are okay with that. Hopefully you don't have other meetings on a Saturday. So you want to actually take this one, and I'll take the next one?
Of course, not a problem. So now we are looking at basically implementations and deployments. So we see a lot of really interesting projects and products even emerging. But also there has been maybe not a growing, but a certain set of issues for version 1.0, so it's for the existing standard that we will aim to address very shortly. We're also looking at issues for the next version, maybe of UMA, maybe 1.1, but if is the best person to comment on this. There is a specific test suite development happening. Well, I would say almost right now. So the work group has accepted some funding for developing a test suite that would allow all the interested implementations to sort of check their conformance to the specification. Again, there might be some revisions for errata in the third quarter of this year. The testing, as discussed, will target the end of the year, and I don't know if maybe we would like to share more information.
Yeah, why I call it roll-in testing. Yeah, so it used to be that cross-matrix testing was really favored, and based on the good experience, I would say, with the recent OpenID Connect self-certification conformance testing, this notion of having a test suite that is well vetted as representing what the specs say, and then testing to that. It's been really productive and efficient, but I'm not sure that we're willing to say that our test suite is an official conformance test suite yet by the end of the year. But I sort of coined this term Roland testing, even if, I mean, we are working with Roland Hedberg, but the idea of testing to his test suite, maybe it should be lowercase Roland testing if it's not a test suite developed by him, but that's what we're planning to do by the end of the year. So there you go.
Right.
All right,
okay.
so in the service of, yeah, go ahead.
But right, and I was just about to say that obviously we currently have a recommendation, so it's a Kantara recommendation, but if I understand that we will be targeting for an IETF independent submission, so maybe that's something also we'd like to share more information about.
Yeah, it seems we've been submitting IETF internet drafts all along, and it seems to be attractive to keep those up to date, not let them expire, and to go on this path. We've talked to a number of folks who find that attractive, so this is our current plan. Last thing, I don't want to keep people too long. We talked a little bit about binding obligations already. We do have a third spec we're working on. We're turning our attention more to it now. We did get some questions in the chat about trust frameworks and access federations and so on. The idea is that, you know, we're talking here about authorization as a service, kind of like you have IDPs and relying parties. We're talking about authorization providers, or what I now sometimes call AZPs and AZRPs, and that's tricky. And we want to make sure that, you know, Alice's wishes really are respected in a system with, you know, our marvelous spiral had a lot of bubbles in it. And that Bob also has his wishes respected. And all these parties really, you know, feel safe doing this, and that the liability gets apportioned correctly. And this is kind of a young art. You know, we only just saw the state of Virginia in the U.S. get a federated identity law around liability just, you know, a couple months ago. So we're trying to do our best to help the world create trust frameworks successfully around UMA deployments as best they can. So our early work around this is called the Binding Obligation Specification. We don't know if it's the right approach, but we're actually working with a number of expert lawyers in the space right now. There's a lot of opportunities for liaisons, and we're taking advantage of those. And you can see here kind of what we're working on around this wording, where you saw the names of the technical entities, and these uppercase names are the names of the parties. So, you know, where let's say if you had Google running an authorization server, they would be an authorization server operator, for example. And the idea is that you could attach new contractual clauses to specific junctures when an UMA message flows somewhere, because that means that two of the parties could have experienced a message that each of them could log. So we're playing around with that. We're having lots of conversations with folks, and we're really trying to do our part to ensure that the new world of kind of modern trust frameworks is well supported by what UMA is trying to do. I predicted on webinar Take One that 2015 will be the year of the modern trust framework, and I really believe that. So we'll conclude there and give people back the rest of their Saturdays. We just want to thank all of the humanitarians who have helped UMA get to version 1.0. I want to especially thank Domenico Catalano, who's been our graphics editor and wonderful talent when it comes to anything visual all this time. He made that wonderful spiral and all the spirals we've had. Any final questions before we close? I think we got to everybody's questions. So with that, I think we will Oh, let's see. Great opportunity for authorization as a service if somebody would build a good UX. Yes. I think everybody is working with Alacrity on exactly that point for sure. Graph representation, yes. You know, not to be too much of a plugging something, but I know that some of my colleagues are working on graph technology pretty heavily, and at the summit that's going to take place just in less than a couple of weeks here in Half Moon Bay in California, I know that they'll be showing some things. I'm intrigued by Maciej's showing the conceptual work on graphs as well. Graphs are a big part of, I think, the Internet of Things because the sheer number of everything is overwhelming. So I think graphs are really coming to the fore as well right around now. Well, thanks everybody for attending on this Saturday. I hope you have a good rest of your weekend. And we'll put this recording up as soon as we possibly can. Thank you.
Thank you, everyone.
Bye-bye all.
As well. Bye.